Continuing our conversation of inverses and inverse functions. An inverse function f inverse, by the way, the exponent -1, in the context of functions, does not mean reciprocal. It only applies to inverse functions. Pardon me, I should have gotten that out a little bit earlier, but it's really important to notice that it's more noted as a point of notation rather than an exponent. It is not an exponent. The inverse function f inverse, or f -1, is the undoing of the function f. For example, the operation sine is undone by the inverse. And what do we call this? It's not sine to the -1, it's actually called inverse sine. The inverse, f inverse, of a function is the reverse of the operations done by the function f. So if f does, f inverse undoes. Do you know what the inverse of the inverse function is? That's right. It's just the regular function. So what we are going to be doing here is we're going to be algebraically defining or deriving the inverse function of each of these. Now, it comes from the main thoughts come from our notations where the x's and y's are switch. And this will, no doubt, happen algebraically. So I'm just going to make a quick sketch of this graph, and I'm good. Don't worry, this is a linear function. So if I take a look at my f of x, and f of x is an inverse or a linear function, it is a one-to-one function, passes both the vertical and horizontal line tests. Fair enough. Don't really need to have to worry about restricting it. So first thing I'm going to do is I'm going to get rid of my functional notation just to make x's y, or just to make my f of x a y, so that it makes a little bit more sense in my brain. So instead of getting rid of or thinking of f of x, I'm just going to think of it as y. Now, this is the important part. This is the inverse. So really, I'm going to swap x and y. I'm going to do that and see where I'm at. Now, I'm going to switch colors. Well, this is actually the inverse function at the moment. So now, I am just going to isolate y. Sorry, that was terribly spelled wrong. I'm just going to isolate y. I'm going to spend all this time isolating y. So really, I think probably the first thing I'm going to do is I'm just going to move what it was ever on the right to the left, whatever is on the left to the right. In other words, I like it when y is over on the left side. It's easier for me. I don't know why. So now I'm going to algebraically isolate for y. The first thing that I would do was probably add 4 to both sides. The next thing that I would probably do is divide both sides by 2. And there's my inverse function. So I'm going to isolate y, add 4 to both sides. And this one, I would say divide both sides by 2, and I'm done. Now, the last step I'm going to do is I'm just going to reintroduce functional notation. So instead of calling it y, I'm going to call it f inverse. Because if this did, this should undo. So f inverse is simply x plus 4 over 2.